The enigma of the past. What if the past is not gone? What if it is not just a memory fading into the mist of time, but still exists somewhere, perhaps just outside our perception, lingering like a forgotten shadow? Imagine for a moment. The moment you first learned to ride a bicycle, the first kiss, the taste of your childhood favorite meal. These moments feel distant now, but what if they're not lost in the corridors of time? What if they are still unfolding, happening somewhere in the vast, unknowable expanse of the universe, waiting for us to reconnect with them? This idea, seemingly impossible and unsettling, forces us to confront a question that has echoed throughout philosophy and science for centuries. Does the past truly cease to exist, or does it persist in ways we can't perceive? As we explore the question, we begin with time itself, that great river that flows from one moment to the next. In our everyday lives, we treat time as something constant, something linear. The past is what has happened, the present is now, and the future is yet to come. But what if time itself isn't the tidy, ordered progression we think it is? What if the past, the very thing we believe to be gone, is still alive, still echoing in some far corner of the universe? Imagine standing in front of a massive river, watching the current carry leaves and twigs downstream. You see the river as it flows, moving from the past to the future. But in reality, that river's current doesn't carry the water of the past. The water is still there, having already passed the same point. It remains in place even as the future moves forward, unchanged. This image, as simple as it seems, is a metaphor for time itself. But if the past never completely dissipates, if it somehow persists, it raises a deeper, unsettling question. Why don't we see it? Why is it not immediately accessible to us like the present? Is the past buried so deeply that we simply cannot perceive it? Or is it that we've been wrong all along in our understanding of time itself? This documentary sets out to challenge everything we thought we knew about time and history. It explores the notion that time may not be as linear as we assume. From the smallest quantum fluctuations to the vast sweep of cosmic history, we begin to ask, could the past still be happening? Could history, the moments, events, and people we once knew, be continuing in some form, just beyond the edges of our perception? To kickstart this exploration, we'll look at the flow of time, not as a simple forward progression, but as a shifting, layered entity that contains both the past and the future in ways that challenge our understanding. Throughout this journey, we will introduce you to thought experiments, scientific theories, and philosophical musings that suggest the past might not be dead and gone, but may in fact be a continuum, an echo that reverberates through the present. In unexpected ways, the first idea we must wrestle with is the nature of memory. What are memories, if not our internal connection to the past? Memories form the bridge between who we were and who we are. They connect us to events, places, and people long gone. But could memory be more than just a psychological phenomenon? Could it be evidence of something more, something deeper and more cosmic? Are we, in our very ability to recall the past, tapping into something that exists outside of ourselves? As we dig deeper into quantum mechanics, we encounter ideas that suggest time might not even be as unidirectional as we think. In the quantum world, particles do not behave in a linear fashion. Quantum entanglement, for instance, shows us that two particles, once connected, can influence one another instantaneously, no matter how far apart they are. This instantaneous connection challenges our understanding of time and causality. Could this phenomenon somehow imply that the past and present are not separate, but instead are deeply interconnected, perhaps in ways we do not yet understand? Beyond, the quantum-level cosmology presents us with even more profound possibilities. We know that the universe, at its origin, began in an event known as the Big Bang. But this raises the question, if the universe began as a singularity, an infinitely dense point, how did time itself begin? Was time, like matter, created in this event? Or did it exist before the Big Bang? Could time, in fact, be something that existed outside of the boundaries we've created for it, a force that simply exists unbound by the physical realities of our universe? Even more speculative ideas suggest that time might not be an absolute feature of reality. What if time, instead, is a subjective experience, a construct of consciousness created by our mind as a way to make sense of the universe? Could it be that the flow of time as we experience it is just an illusion, one that our minds create to organize events and memories, while the true nature of reality is something that lies beyond our limited understanding? As we journey through this documentary, we will also revisit some of the most famous thought experiments that have tried to tackle the enigma of time. Concepts such as the block universe theory propose that past, present, and future might coexist, simultaneously suggesting that the past could be just as real as the present, existing in a timeless continuum. This view, though radical, invites us to consider the possibility that time, far from being a strict, forward-moving progression, is a layered experience, one where the past is not gone, but exists alongside the present, waiting to be reconnected with. As we piece together these ideas, we are led to a profound realization. The past might not be lost. Instead, it might be waiting for us to perceive it differently, to rethink the way we understand time and memory, to challenge the belief that time is simply a linear, unidirectional force. What if the past is not gone but is still there, existing, in a form we cannot yet comprehend? And so we begin our journey not just through the mysteries of time, but through the mysteries of existence itself. We will explore the very boundaries of reality, asking whether time is a fixed, absolute force, or if it is something far more mysterious, a force that exists beyond the limits of our understanding. The nature of time. Flowing or cyclical. Time is a concept we all experience, yet it remains one of the most elusive, perplexing forces in our understanding of the universe. We measure time with clocks, divide it into seconds, minutes, and hours, and live by its rhythm day by day, year by year. But what is time really? Is it a force that flows forward, unstoppable, from past to present to future? Or could time be cyclical, repeating itself in an endless loop, where the past and the future are not so distinct, but instead part of a continuous cycle? To understand the true nature of time, we must first explore two competing views: the traditional idea of time's arrow and the concept of cyclical time, time's arrow, a one-way journey. For most of human history, we've thought about time as a linear progression, something that moves forward in one unbroken line. This is the arrow of time, a phrase coined by physicist Arthur Eddington to describe the direction in which time flows. According to this view, time starts at a certain point, moves forward, and never turns back. It is often depicted as a river, flowing relentlessly from past to present to future. This view of time aligns with everyday experience. We see ourselves aging, growing older with each passing moment. Events unfold in a linear sequence, and the future is always ahead of us. When we look back, we see the past behind us, always receding, forever out of reach. Time moves forward, and we move with it, but the idea of time as a straight line, always moving in one direction, is rooted deeply in classical physics. In the early 20th century, Einstein's theory of relativity provided a scientific framework that cemented this view of time. According to relativity, time is intertwined with space, forming what we call space-time. Time itself behaves like a river, but it is influenced by factors like gravity and velocity, causing it to stretch, bend, and curve depending on where you are in the universe. Time, according to this theory, flows forward for everyone in the universe, although the experience of time may vary depending on how fast you're moving or how close you are to a massive object like a planet or star. The second law of thermodynamics also supports this view of time's one-way progression. It states that the universe tends toward greater entropy, a measure of disorder over time. As entropy increases, systems become more disordered, and the past becomes fundamentally different from the future. Entropy provides a natural direction for time. It always moves toward more disorder, which means the future is always more disordered than the past. This gives time its unidirectional flow, the arrow of time. But is time truly fixed in one direction, as we've always believed? This straightforward view of time has deep philosophical implications, suggesting that the future is unpredictable and always ahead of us, and that the past is fixed, immutable, and forever gone. The cyclical view of time, repetition and renewal. What if time is not an arrow but a cycle, an eternal loop, where the past and future are not so clearly distinct and time repeats itself in endless cycles? The idea of cyclical time has deep roots in both ancient philosophy and modern cosmology. Many ancient cultures believed in the cyclical nature of time, where everything in existence would eventually return to a starting point, only to begin again. In Hinduism, for example, the concept of samsara describes the cycle of birth, life, death, and rebirth, a never-ending wheel that turns continuously. The universe, according to this view, is always in a process of renewal, with time repeating itself in an infinite loop. The cycle of life and death, creation and destruction, is seen as a fundamental feature of reality itself. Similarly, ancient Greek philosophy, particularly in the teachings of Heraclitus, described time and existence as a constant cycle of change. According to Heraclitus, the universe is in a state of perpetual flux. Nothing is ever fixed, and everything is constantly in motion, renewing and transforming. This cyclical view suggests that the past and future are not linear, but part of an eternal, recurring process. Even in modern cosmology, the idea of cyclical time has emerged in certain models of the universe. The Big Bang Theory describes the birth of our universe from an incredibly dense singularity about 13.8 billion years ago. However, some theories, like the Big Bounce, propose that the universe does not simply have a beginning and an end, but instead undergoes repeated cycles of expansion and contraction. In this view, the universe expands from a singularity, like the Big Bang, until it eventually contracts back into a singularity in a big crunch. After that, the cycle begins again, with time continuing in an eternal loop. This model suggests that time is not a straight line, but a cycle, a continuous, infinite loop. The interplay between linear and cyclical time at first glance, the idea of cyclical time may seem at odds with our everyday experience of the world, where we perceive time as a linear progression. But when we examine these two views, time's arrow and cyclical time, we realize that there may be ways they can coexist. Linear time, as we experience it, may simply be a product of our perception, a mental construct we impose on a universe that is far more complex than we can fathom. One possible way to reconcile these two views is through the idea of time as a fractal. In this model, time might not move in a simple one-way direction or in a perfect cycle, but instead in a self-replicating pattern. Much like a fractal, where each part of the whole mirrors the whole itself, time could repeat in cycles, but those cycles might contain different levels of repetition. The present may feel like a new moment, but the pattern of events may repeat itself across different scales of time, suggesting that the past might still be influencing the future in ways we cannot yet fully understand. Is the past truly gone? Now, we return to the question we set out to explore. Is the past truly gone? The answer may lie in our understanding of time itself. If time is cyclical, then the past might not be lost at all. It might still be happening, just beyond our perception, ready to repeat itself in the eternal flow of time. Even if time is linear, it's possible that the past doesn't simply vanish, it may still exist in some form. In the block universe theory, for example, all points in time past, present, and future exist simultaneously. In this model, time is not a flowing river, but a static block, a universe in which all moments, past and future, are equally real and existent. And then there's the possibility that time itself is a construct of consciousness, a way for our minds to organize and make sense of the world. If time is subjective, and if it is shaped by how we perceive the world, then perhaps the past isn't gone at all. It could be lingering in our memories, in the imprints of experience we carry with us, waiting to be reconnected. As we explore these ideas, time's arrow, cyclical time, and the possibility that the past never really disappears, we are confronted with a cosmic question. What is the true nature of time? Is it the linear progression we experience, or does time loop, bend, and stretch in ways we cannot yet understand? And most intriguingly, could it be that the past is still out there somewhere, affecting the present in ways we've never imagined? The block universe. All time exists simultaneously. Imagine for a moment standing on a mountaintop looking out over a vast landscape. Below you, the river flows, carving its path through the valley, winding its way around trees and boulders. From your vantage point, you can see the entire course of the river, its past, its present, and its future all at once. The river, though, it seems to flow has, in a sense, already been mapped out, its course laid out before you in all its movements, each twist and turn fixed within the landscape. Now imagine that this view is not just limited to the river, but applies to time itself. What if time, like that river, isn't a flowing stream but a landscape, a vast, unchanging block in which the past, present, and future all coexist simultaneously? What if, instead of thinking of time as something that moves forward one moment, unfolding into the next, we understood it as a single, four-dimensional block where all events are fixed, equally real, and unchanging? This is the idea behind the block universe theory, a radical view of time and reality that challenges everything we think we know about the flow of time. According to this theory, time is not linear. It doesn't move from past to present to future in a one-way progression. Instead, all points in time, past, present, and future, exist simultaneously as part of a single, unchanging block of space-time. Einstein's theory of relativity, the fabric of space-time. The block universe theory owes much of its foundation to the work of Albert Einstein and his theory of general relativity. Before Einstein, time was thought to be a constant, the same for everyone, regardless of where you were or how fast you were moving. But in Einstein's groundbreaking theory of relativity, time was shown to be anything but constant. Instead, time is intertwined with space in a unified fabric known as space-time. Relativity tells us that time behaves in a way that is deeply influenced by the force of gravity and the relative motion of observers. Time is not an independent, fixed flow. It can stretch, compress, and even bend depending on your speed and the presence of massive objects like stars or black holes. Einstein's theory shows us that space-time is dynamic, not static, and this dynamism leads to a view of time that isn't as straightforward as we once thought. In Einstein's framework, time is relative. It varies depending on your perspective. If you were to travel near the speed of light, time would appear to slow down for you compared to someone who is stationary on Earth. This is known as time dilation, and it's a direct consequence of the way space-time behaves under relativity. To an astronaut traveling at high speed in space, time would pass differently than it does for someone on Earth, and if they returned to Earth after many years of space travel, they would have aged less than the people they left behind. But beyond these practical consequences of relativity, there is a deeper implication: the idea that time is not a one-way street. If we accept that time is relative and that it can bend in response to motion and gravity, it begins to suggest that time is not linear. In fact, this way of thinking opens the door to the block universe theory, which proposes that all moments in time exist equally and simultaneously. The block universe, a four-dimensional space-time. In the block universe, time is not something that passes. Instead, it is a dimension just like space. And just as all locations in space exist simultaneously, the mountain top, the valley, the river, they all exist at once, so too do all events in time. The past, present, and future do not flow into one another. They are all part of a single four-dimensional block of space-time. This idea can be difficult to grasp because it contradicts our everyday experience of time. In our daily lives, time feels like a river. The past is behind us, the future ahead, and the present a fleeting moment we can never quite hold on to. But in the block universe model, this flow of time is merely an illusion. Time in reality is like the landscape from the mountaintop, where all moments in time coexist and are equally real. In this view, the past doesn't cease to exist. It remains fixed within the fabric of space-time, just as real as the present. When we look back on our memories, we are not simply recalling something that no longer exists. Instead, we are tapping into a part of space-time that is still there, embedded in the structure of reality. The moment you experienced yesterday, the event that occurred years ago, are still present in a different form within the block of space-time. They are fixed and unchanging, awaiting to be revisited as part of the larger fabric of time. The implications for time and the past. If the block universe theory is true, it raises profound questions about the nature of the past and our relationship to it. In the linear view of time, the past is something that slips away, always receding into history. It is gone, irretrievable, immutable. But in the block universe, the past is not lost. It is still there, just as real as the present. This suggests that the past is not gone in the way we think it is. Instead, it is preserved, existing as part of a timeless structure. This view challenges our conventional understanding of memory, history, and even free will. If all events, past, present, and future, exist simultaneously, what does that mean for our sense of choice and agency? Do we truly have the power to alter the future, or is it already laid out, fixed within the fabric of space-time? Some proponents of the block universe theory argue that this view does not negate free will. They suggest that even though the future is fixed within the block, we experience it as if it were unfolding, and our perception of the passage of time is what gives us the illusion of change. The block universe doesn't deny the reality of experience. It just shifts our perspective on how time works, suggesting that all moments are equally real, even if we can't access them all at once. Time and the fabric of reality. The block universe theory also suggests that time is inseparable from space. It is not a separate force, but part of the fabric of reality itself. In the same way that space doesn't simply exist in a single point, time is not a series of isolated moments. Instead, time and space are woven together in a single, unified whole. Every event in time is a part of this whole, existing simultaneously within the structure of space-time. This four-dimensional space-time is the reality we inhabit, even if we can only perceive a three-dimensional slice of it. This raises the possibility that the past, present, and future could all be interwoven, forming a complex network of events that coexist in ways we don't yet fully understand. While we may experience time as a flowing river, the block universe theory suggests that the universe is, in fact, a vast, unchanging landscape where all moments are preserved and interconnected, just waiting for us to experience them. A nude perspective on time and reality. The block universe theory offers a radically different view of time, one where the past is not gone but still exists in a fixed, eternal present. It challenges us to rethink our perception of time as a flowing river, urging us to see it instead as a complex, multidimensional structure where all events are real, equally present, and interconnected. As we consider this idea, we are left with a profound mystery. If time is not what we think it is, what else might be different about the nature of reality itself? Quantum mechanics, time, uncertainty, and the multiverse. Time, an ever-present force that shapes everything in our lives, from the beat of our hearts to the ticking of the clock. It's something we think we understand, or do we? In the classical world, time is predictable. It's a linear progression stretching from the past to the future. We measure it with precision, charting the unfolding of events with the assumption that time flows in a constant, unidirectional stream. But when we look closer, beyond the everyday world, we find that time behaves unpredictably at the most fundamental level of reality. Enter the world of quantum mechanics, a realm where the rules of time, space, and cause and effect break down in ways that defy all logic. In this strange world, time doesn't behave according to the neat, linear progression we expect. Instead, it becomes fluid, uncertain, and sometimes even disjointed. Concepts that seem so simple, like past, present, and future, start to blur into something far more complex. In quantum mechanics, time is not just a force, it's a mystery, one that stretches the boundaries of what we thought we knew about reality. The uncertainty principle. Time and uncertainty. The foundation of quantum mechanics is built on the principle of uncertainty, first proposed by Werner Heisenberg in the 1920s. Heisenberg's uncertainty principle states that there are limits to how precisely we can know certain pairs of properties of a particle at the same time, such as its position and momentum. The more accurately we try to measure one, the less accurately we can know the other. This uncertainty doesn't arise from technological limitations, it's a fundamental property of nature itself. This principle doesn't just apply to position and momentum, it extends to time as well. The more precisely we try to measure the time at which an event occurs, the less we can know about the event's duration or other properties. This suggests that at the quantum level, time is not as fixed and linear as we think. Instead, time is part of the uncertainty that defines the quantum world. In a quantum system, particles don't exist in a single, well-defined state at any given moment. They exist in a superposition of all possible states with the probability of each state determined by a wave function. Only when we observe the system does the wave function collapse, and the particle takes on a specific position or momentum. In this way, time is intertwined with uncertainty. The moment we look at the system, time seems to freeze, and a particular outcome is realized. But what happens when the quantum world of uncertainty interacts with our perception of time? Does this blur the lines between the past, present, and future, suggesting that time itself is as unpredictable and indeterminate as the particles that populate this strange realm? Quantum superposition, multiple realities and parallel timelines. The uncertainty principle tells us that particles exist in multiple states at once until we measure them, at which point they collapse into one specific state. But this idea leads to a more startling concept, the idea that every moment in time could exist in multiple parallel versions of reality. This brings us to quantum superposition, a phenomenon where a particle can be in multiple places or states at once. This is not an abstract concept, it has been experimentally confirmed. In the famous thought experiment known as Schrödinger's cat, a cat in a box can be both alive and dead at the same time, existing in a superposition of states until observed. In the quantum world, particles, like the cat, do not choose a definite state until they are measured. But the implications of quantum superposition stretch beyond just particles. It suggests that every moment in time could be a branching point, with multiple possibilities existing simultaneously in different parallel realities. In other words, at every moment, time could split into multiple timelines, each one representing a different outcome of a single event. This idea is known as the many-worlds interpretation of quantum mechanics. According to this interpretation, every time a quantum event occurs, the universe splits into multiple parallel realities, with each possible outcome existing in a separate coexisting timeline. So if a decision is made, say, you choose to go left instead of right, each possibility creates a separate timeline where a different version of reality plays out. This means that the past, the present, and the future are not single, linear events, but parallel threads of time, constantly splitting and diverging into multiple possibilities. The many-worlds interpretation, a parallel universe of past, present, and future. The many-worlds interpretation paints a picture of the universe that is radically different from our everyday experience. Instead of a single, continuous timeline, we live in a multiverse, a vast, interconnected network of realities, all branching from each other, each existing in parallel, with each moment in time giving rise to countless possible futures. But what does this mean for the past? If every moment creates a branching timeline, then could the past be replayed in different forms across multiple parallel worlds? Could the version of the past we experience be only one of many, each of which exists simultaneously in a different timeline? The idea that the past is fixed, unchanging, and forever gone is called into question when we consider that each possible outcome of the past could exist in parallel universes, with each version of the past replaying over and over in an infinite number of realities. In a universe governed by the many worlds interpretation, the past is not just gone, it is still there, existing in an endless web of possible histories. Every moment of history could branch out, creating multiple versions of events, each interconnected in an intricate web of possibilities. The idea of a single, linear past is replaced by the notion of an ever-expanding multiversal timeline, where the past, present, and future all coexist in infinite parallel realities. Time in the many worlds universe. Constant replay or infinite. Possibilities? What does this mean for the experience of time? In the many worlds model, time is no longer a fixed progression from past to present to future. Instead, time becomes a fluid, branching process, where each decision, each quantum event creates a new branch, a new path. The past, rather than fading away into irretrievable history, is perpetually replayed, constantly revisited in different versions of reality. This view of time raises profound questions about our perception of history. Could the past be more alive than we thought? Could different versions of the past coexist, constantly interacting with the present? Could the decisions we make in the present be influencing alternate versions of the past, creating a dynamic web of timelines that are interconnected, even if we can't perceive them? We begin to see that time, as we understand it, is not a single, fixed flow, but a vast, unfolding network of possibilities. The multiverse of time means that what we think of as the past, our personal history, our collective history, could be far more dynamic, far more mutable than we've ever imagined. The nature of time and the multiverse. What lies beyond our perception? As we consider these ideas, we are left with a mystery one that calls into question everything we thought we knew about time. If time can split into multiple realities, if the past can persist in parallel worlds, if the future is a series of possibilities yet to unfold, then what does it mean for the nature of time itself? Could it be that time, rather than being a linear progression, is actually a vast, interconnected web of realities, each one existing simultaneously? In the quantum realm, time is not the steady, unchanging force we think it is. It is unpredictable, uncertain, and multifaceted, branching off in multiple directions, creating a network of timelines that exist side by side in parallel. As we peel back the layers of quantum reality, we begin to see that the very nature of time is far more complex than we can ever truly comprehend. Time travel. Can we visit the past? For centuries, the idea of time travel has captured our imaginations. From H.G. Wells's classic novel, The Time Machine, to the countless science fiction movies and TV shows that followed, time travel has become synonymous with the possibility of visiting the past, of journeying back in time to witness history, meet past versions of ourselves, or perhaps even change the course of events. But while time travel is a staple of fiction, what does science have to say about it? Is it merely a fantastical idea, or could it be possible that time travel, as we imagine it, could one day become a reality? The dream of time travel raises profound questions about time itself. Is time a fixed, immutable flow, or is it possible to navigate through time much like we move through space? Could the past, the present, and the future be as accessible as different locations on a map? And if so, what might that mean for our understanding of reality, history, and the very fabric of the universe? In this section, we will explore the scientific theories that underpin the possibility of time travel, delve into the paradoxes that come with it, and ask the question, could we truly visit the past, or is it a concept that exists only in the realm of speculation and imagination? Theoretical underpinnings of time travel. The notion of time travel is more than just science fiction. In fact, some of the greatest minds in physics, including Albert Einstein, have entertained the possibility of time travel. At the heart of these theories lies the idea that time is not a constant, immutable force, but is deeply connected to space, forming what we know as space-time. According to Einstein's theory of general relativity, space-time is a curved fabric, and time is not a fixed quantity that flows independently, but is affected by the mass and energy of objects in the universe. One of the most intriguing aspects of Einstein's theory is the concept of wormholes, hypothetical passages through space-time that could, in theory, connect distant points in both space and time. A wormhole is often described as a kind of shortcut through space-time, a tunnel-like structure that could potentially allow for time travel. If such a passage existed, it might allow one to travel backward or forward in time, much like stepping through a doorway to a different moment in history. But while the idea of wormholes is tantalizing, they remain entirely theoretical. There is no experimental evidence to suggest that wormholes exist, and even if they do, there are numerous obstacles to making them useful for time travel. For one, the energy required to create and sustain a wormhole might be far beyond anything we could currently imagine. In addition, the nature of the quantum foam that underpins space-time might prevent wormholes from being stable or traversable. Yet despite these challenges, the idea of time travel remains a serious topic of theoretical discussion. Some physicists believe that with the right conditions, such as the presence of exotic matter or the ability to manipulate space-time at a quantum level, time travel could one day be possible, even if it seems like a distant possibility. Traversing the past. Could we visit the past? So, if time travel were possible, could we actually visit the past? This question takes us deep into the realm of speculation and paradoxes. On one hand, we have the notion that time flows one way, from past to present to future, and that the past is fixed no matter what we do. The events of history have already unfolded. If time is a straight line, traveling backward in time seems like an impossible task. Yet, if time is more fluid or cyclical, the idea that we could access the past might seem more plausible. One possible way to travel to the past, according to some scientists, could involve using a rotating black hole or a wormhole that connects the present to an earlier moment in time. But even if we could somehow travel backward through time, we would still face the dilemma of whether the past is truly gone or if it still exists in some form, somewhere in the vast stretches of the universe. This brings us to another fascinating possibility. Could the past, as we understand it, still exist somewhere in the universe, even if we can't directly access it? If the universe operates according to principles we don't yet fully understand, it's conceivable that the past could be recorded in some way, preserved as part of the fabric of space-time, waiting to be discovered. Some physicists speculate that quantum information, the fundamental data that describes the state of all particles in the universe, might encode the history of the universe, making the past, in a sense, eternally accessible. Paradoxes of time travel, causality and history. However, the concept of time travel isn't without its paradoxes, many of which arise from the inherent contradictions that occur when we attempt to travel to the past. Perhaps the most famous of these is the grandfather paradox, a thought experiment that asks, what happens if you travel back in time and prevent your grandfather from meeting your grandmother? If that happens, you would never have been born, which means you could never have traveled back in time in the first place. This creates a logical contradiction. If you prevent your own existence, how could you go back in time to change it? The grandfather paradox presents a fundamental challenge to the very idea of time travel. If time is a fixed sequence of events, then traveling to the past and altering key moments in history could create causal loop situations where events contradict themselves. This raises the possibility of multiple timelines or parallel universes, where each change to the past creates a new reality, one that coexists with the original. Some physicists have proposed that these paradoxes might be resolved through the idea of the many worlds interpretation of quantum mechanics, which suggests that each decision or change in the timeline results in the creation of a new parallel universe. In this framework, traveling to the past doesn't alter the original timeline, but instead creates a new one, a new version of the universe where events unfold differently. Thus, time travel could allow us to visit the past, but only in the sense of creating new parallel timelines where the past exists alongside the present in multiple realities. The nature of history. Can we really change the past? If time travel were possible, it would raise profound questions about the nature of history. Would the past be something we can change, or is it a fixed, immutable sequence of events that simply cannot be altered? And if time travel creates new timelines, does that mean that history itself is constantly being rewritten, creating an infinite number of parallel worlds, each with its own version of the past? These questions blur the lines between science, philosophy, and the nature of reality. In a universe where time travel is possible, the past may not be gone in the way we think it is. It could be accessible, but only in ways we can't yet fully comprehend. Perhaps the past exists not as a single, static event, but as a multiverse of possibilities, each one playing out in parallel, constantly shifting and evolving, never truly fixed. Conclusion: time travel and the future of reality. As we contemplate the possibilities of time travel, we are faced with more questions than answers. Can we truly visit the past, or is the idea of changing history a fiction of our imagination? Is the past already preserved, accessible in some unknown way through the fabric of space-time? And if time travel is possible, what does that mean for the very nature of causality and history? These mysteries challenge our understanding of time, space, and the universe itself. Time travel may seem like a fantastical concept, but the very possibility of it raises profound questions about the nature of reality and what lies beyond our current understanding of time. The nature of memory. Is the past living with us? Have you ever found yourself lost in thought, revisiting a moment from your past, perhaps a childhood memory, a conversation, or a feeling? As you replay it in your mind, does it feel like it happened just yesterday, even if it occurred years ago? Our memories are not static. They are vivid, active, and constantly shaping the way we perceive ourselves and the world around us. Memory is often thought of as a mere snapshot of events that happened in the past. But what if memory is more than that? What if it is not just a passive record of what we've experienced, but a living, breathing history that continues to shape us, to influence our thoughts and even our actions? Could the past actually be alive within us, not just as a mental archive, but as something that actively exists in the present moment, woven into the fabric of our consciousness? In this section, we explore the nature of memory, how the brain constructs and stores memories, and what it means to live with the past. As we dive deeper, we'll examine the philosophical implications of memory, raising the question, could the past persist, not just in the physical world, but within our consciousness itself, still active and alive? A living history. When we think of memory, we tend to imagine it as a record, a series of snapshots or video clips from the past, neatly stored away in the brain. But the reality of memory is far more complex. Memories are not just static images or precise recordings of events. They are fluid, dynamic, and in many ways, constructed by our minds each time we revisit them. The brain does not store memories like a hard drive, recording every detail in exact, unchanging form. Instead, memories are reconstructed every time. We recall them shaped by our current state, emotions, and even our expectations. In a sense, our memories are alive, constantly being updated and reinterpreted as we experience new things. We don't simply retrieve memories from the past, we recreate them each time we think about them. But what does this say about the nature of the past? If memories are constantly reshaped and reimagined in our minds, does that mean that the past is not fixed but alive, constantly influencing us in the present? Could the past live on, not just as a recollection, but as an active presence within our consciousness? The brain's construction of memory. To understand how memory works, we must first look at how the brain processes and stores experiences. Memory is not a single process. It involves multiple regions of the brain working together to encode, store, and retrieve information. At the heart of memory is the hippocampus, a small seahorse-shaped structure deep within the brain that is essential for forming new memories. When we experience something, the hippocampus works to convert that experience into a long-term memory. But this process is far from perfect. The hippocampus takes bits and pieces of the experience, the sights, sounds, smells, and emotions, and stores them in different areas of the brain, creating a network of information that forms our memory. However, memories are not stored as perfect snapshots. Instead, they are reconstructed each time we recall them. The brain does not retrieve a perfect recording of an event. Rather, it reconstructs the experience based on the information available at the time. This is why our memories can sometimes be distorted or fuzzy, influenced by our emotions, our beliefs, and even the passage of time. In fact, research has shown that memories are not just recalled, they are recreated in our minds each time we think about them. This process is influenced by a variety of factors, including our emotions and current mental state. For example, a memory of a childhood event may feel different depending on whether we are feeling happy, sad, or anxious. Our mood can alter the way we experience the past, making memories seem brighter, darker, or even distorted based on our emotional context. This reconstructive nature of memory raises a profound question. If the past is constantly being recreated and reshaped in our minds, does that mean the past is not just a record of events, but a living part of us, one that is actively alive, shifting and evolving as we continue to experience and reinterpret it? Memory and time, the past, present and future. When we think about memory, we typically associate it with the past, the events we've lived through, the people we've met, and the experiences that have shaped us. But memory is not just about remembering what has happened. It also plays a crucial role in how we experience the present and how we anticipate the future. Our memories inform the way we navigate the world. We use past experiences to make decisions, predict outcomes, and interpret new events. Memory allows us to learn, to build upon what we've already experienced, and to shape our understanding of reality. In a sense, the past is constantly shaping the present, influencing how we act, how we think, and how we relate to the world. But what if memory is more than just a mechanism for navigating the present? What if memory is also the key to understanding the nature of time itself? Could the way we experience memory be a reflection of a deeper, more complex relationship between time and consciousness? Could memory in some way suggest that the past is not gone, but alive, not just as a fixed record, but as an active presence that continues to affect us and shape our lives? The persistence of the past in consciousness. This idea leads us to a fascinating possibility. Could the past persist not just in memory, but as an active presence within our consciousness? What if our memories are not merely static snapshots of the past, but living echoes, fragments of history that continue to resonate within us, shaping our present experience? We often think of the past as fixed, something that is no longer accessible, except through memory. But if memory is not a perfect recording, but a dynamic, ever-evolving process, then the past is not something that fades away. It is something that is recreated in our minds every time we recall it. In a sense, the past could be thought of as living history, still influencing us and shaping our perception of the present moment. Some philosophers and scientists argue that memory itself could be a form of time travel, not in the physical sense, but in the way it allows us to experience the past in the present. When we recall a memory, we are re-experiencing a moment from the past in a way that is not unlike revisiting a time long gone. But what if, in this process, the past is not just something we recall, but something that continues to exist in some form within the framework of our consciousness? Philosophical implications. The living past. This idea of the past living within us has profound philosophical implications. If the past is alive within us, constantly reshaped and reconstructed through memory, does that mean the past is not truly gone? Is the flow of time something more fluid than we've realized, with past, present, and future not separate, but interwoven, existing in a more dynamic, interconnected way? Some philosophers suggest that memory could be the key to understanding the nonlinear nature of time. If the past can persist in our minds, if memories are not fixed, but constantly evolving, perhaps time itself is not a straight line, but a series of overlapping moments constantly influencing one another. In this view, the past, present, and future are not separate realities, but interwoven threads continuously shaping and reshaping the fabric of time. The question then becomes, how much of the past is still alive within us? Could we tap into that living history, experiencing the past not just as a memory, but as something that still exists, influencing our consciousness in ways we don't fully understand? Does the present contain the past? Imagine for a moment you're standing at the edge of a vast ocean. The waves crash one after another, each moment slipping away, only to be replaced by the next. You could sit there forever watching the waves, feeling the rhythm of the ocean as it moves through time. But what if, rather than flowing in a straight line, those waves, the past, the present, and the future, are all simultaneously there, existing together in one unified moment? What if time is not the river we think it is, but an illusion, and the present moment, the one we experience, is far more complex than we ever realized? The concept of the eternal now suggests just that. Time is an illusion, and all moments in time, the past, present, and future exist together simultaneously. In this view, the past is not gone, it exists in some way right here, in the very present moment. But how can that be? How can the past, something that seems long gone, still exist in the now? This question challenges everything we know about time, memory, and existence itself. Presentism versus eternalism. Two views of time. To understand this idea, we need to explore two contrasting philosophical perspectives on time: presentism and eternalism. Presentism is the belief that only the present moment is real. According to presentism, the past is gone, it no longer exists, and the future is nothing but a set of possibilities yet to be realized. The present is the only true moment, the only one we can experience. The past is something we remember, and the future is something we anticipate, but neither has any tangible existence outside of our minds. For presentists, the present is a kind of eternal now, but it's a very fleeting one. The past is locked away in the vault of memory, and the future is forever just out of reach. But eternalism offers a different perspective. In contrast to presentism, eternalism posits that all moments in time, past, present, and future, are equally real. Time is not a river flowing forward, but rather a four-dimensional block, where the past, present, and future all coexist. In this view, the past is not gone, and the future is not merely speculative. They exist fixed and immutable alongside the present, all part of a timeless block that includes everything that ever was and ever will be. Eternalism suggests that time is not something that flows. It is something that exists, a vast landscape, where all moments are equally real, equally existent. In this world, the past does not vanish into oblivion, but remains present, coexisting with the current moment. The present doesn't just come and go, it's part of a larger reality, where all moments are contained within it. The eternal now becomes a living, ongoing tapestry of time, where the past is not lost, but always there. Time as an illusion now. Let's turn back to the ocean metaphor. If time is like the waves crashing on the shore, what if every wave is just as real as the one that follows it? What if all the waves, past, present, and future, are not part of a flowing river, but part of an ongoing, timeless cycle? This is where the idea of the eternal now begins to take shape. In the timeless now, everything exists in simultaneous harmony. Time is not a flowing current, but a static, eternal frame where every moment is fixed and present. When we experience time, we are simply moving through this fixed block of moments. But if time is an illusion, a mere perception of our consciousness, then could the past still be alive within us, contained within this eternal now? Think about it. Memories are not simply past events locked away in the vault of the mind. When we remember something, we recreate it, experience it again in the present moment. In a sense, the past is always alive, always replaying itself in our minds. Our consciousness, at any given moment, may have access to different layers of time, conjuring up memories, interpreting them in light of our current state. Could this suggest that the past isn't simply gone, but replayed and re-experienced? In the present, part of the living landscape of time, a bridge between past and future. In the eternal now, the present moment becomes a bridge, not a fleeting instant, but a portal where the past and future coexist. Imagine standing in a room, looking at a wall of mirrors. In each mirror, you see a different reflection of yourself. One from the past, one from the future, and one from the present. Each reflection is real, but they are all part of a greater, unified reality. The present is not just a snapshot in time, it is the intersection of all time past, present, and future. This view of the present as a bridge between past and future suggests that time is not linear, but a circular or spiral entity. It is a loop where each moment exists not independently but interconnectedly, with all moments touching and influencing each other. This kind of holistic time challenges the traditional understanding of time as a one-way flow from past to future. Instead, time is a web where each thread, past, present, and future, is intricately woven into the whole. Can the past be revisited in the present? The eternal now suggests that the past is not something that is forever lost. Rather, it's something that exists within the fabric of the universe, within the very structure of time. The past in this view is preserved within the timeless now. Just as the memory of the past exists within our minds, perhaps the past exists within the fabric of space-time itself. Could we, in some way, access the past, perhaps not in the way we imagine, by physically traveling back in time, but through a deeper conscious connection to the eternal now? This notion hints at the possibility that time travel might not be as distant or impossible as we've been led to believe. Accessing the past might not require traveling through space or time, but rather a shift in perception, a deepening of our understanding of the timeless now. What if the past is already there, waiting to be revisited, not in some future moment, but in the present, always alive, always in reach, if only we could perceive it differently? The implications of the eternal now, time, memory, and reality. The philosophical implications of the eternal now are profound. If the past, present, and future all coexist simultaneously, then the way we think about time, history, and reality must shift. The past is no longer just a collection of memories, fading away with the passage of time. It becomes part of an enduring reality, accessible in ways we don't fully understand. This also raises the question of free will. If all moments in time exist simultaneously, are we simply playing out a preordained script, or do we have the ability to navigate through this block of time, making choices that affect how we experience the present moment? If the past is not gone, if it's woven into the fabric of the present, does that mean we can change it, or at least influence it in subtle ways? Are our memories and experiences more than just records of what happened, but active forces in the timeless now? The past, present, and future as one, as we stand in the present moment, gazing out at the landscape of time, we begin to see that time is not the linear, rigid force we once believed it to be. Instead, time is a multidimensional reality where the past, present, and future are not distinct entities, but parts of a larger, interconnected whole. The eternal now is not just a moment in time, it is the very fabric of existence. In this eternal now, the past is not lost, it is alive, active, and waiting to be rediscovered. The present moment is not a fleeting instant, but the key to accessing all of time, as if all the moments of the universe are always right here, waiting for us to perceive them. The past is not gone, it is living within us, within the universe, within the very structure of time itself. And so the mystery of time deepens. Is time a river, flowing endlessly forward, or is it a landscape where all moments coexist in an eternal now? The answer may lie not in the future, but in the present, where time itself reveals its deepest secrets, waiting for us to uncover them. The holographic universe. Is the past recorded in the cosmos? What if everything we know about the universe, the stars, the planets, the galaxies, wasn't just a three-dimensional reality unfolding in space? What if, beneath the surface of everything we see, the entire cosmos is encoded in a hidden, two-dimensional layer? This is the idea behind the holographic principle, one of the most mind-bending concepts in modern physics. In this view, our three-dimensional universe, along with everything that has ever happened, everything that exists or has existed, could be encoded in two-dimensional information on the surface of a cosmic boundary, much like a hologram. A hologram, after all, can produce a three-dimensional image from just two dimensions of data. Could it be that our entire reality, including the past, is recorded on a cosmic surface, waiting to be decoded? If the holographic principle holds true, it suggests that the past is not gone, but rather preserved, encoded in the very fabric of space-time itself. The universe may be like a cosmic recording, a vast archive of information that includes not just the present, but every moment of the past. Could this mean that the past is still out there, somehow accessible through the very structure of the universe? In this section, we explore the holographic principle, how it connects to black holes and quantum gravity, and what it might mean for our understanding of time, memory, and the past. Is the universe recording its history, and if so, is it possible to access the past through this cosmic imprint? A new way of seeing the universe. The holographic principle was first proposed by physicists Leonard Susskind and Gerard 't Hooft in the 1990s, and it was inspired by the study of black holes. According to traditional physics, a black hole is an object with an immense gravitational pull, so strong that even light cannot escape it. But when scientists looked closer at black holes, something strange became apparent. The information that falls into a black hole, whether it's matter or energy, doesn't seem to be lost. Instead, it appears to be encoded on the two-dimensional surface of the black hole's event horizon, the boundary beyond which nothing can escape. This led to the realization that the information making up the universe, everything we perceive as reality, could also be encoded in a two-dimensional surface, not unlike the way a hologram encodes three-dimensional images in a two-dimensional plane. In essence, the universe itself might be a hologram with the information about everything in it, including the past, stored on the boundary of space and time. This insight connects deeply with the study of quantum gravity, a field of physics that seeks to unify quantum mechanics and general relativity. In quantum mechanics, particles behave unpredictably, existing in multiple states at once. In contrast, general relativity describes the smooth fabric of space-time. The holographic principle offers a potential solution to this tension, suggesting that the three-dimensional nature of space could emerge from two-dimensional data encoded on the boundaries of the universe. In this framework, time is not simply a linear progression, but could be understood as a manifestation of the information stored on the cosmic surface. The holographic universe, a cosmic recording of history. If the holographic principle is correct, then every moment in time, every event is encoded in a way that is far more complex and intricate than we ever imagined. Just as a hologram contains three-dimensional information on a two-dimensional surface, the universe could store information about everything that has ever happened within the very fabric of space-time. This includes the past, which, according to this theory, would not be lost, but instead recorded and preserved. In essence, the universe could be recording its own history, not just in the way we experience it, but as an eternal imprint in the structure of space-time itself. The information about the past, the events, the choices, the interactions between particles, the formation of stars and galaxies might be encoded in the very geometry of space-time. This suggests that the past doesn't simply disappear. It is, in a sense, preserved in the cosmos, waiting to be accessed. But how could we access this cosmic recording? How could we, as conscious beings, connect with this hidden layer of the universe where the entire history of reality is encoded? Could We, in some way, revisit the past, not by traveling back in time, but by decoding the information stored in space-time. Black holes and the holographic principle, a window to the past. One of the key pieces of evidence supporting the holographic principle comes from the study of black holes. In 1975, the physicist Stephen Hawking discovered that black holes, rather than being completely impenetrable, actually emit radiation, a phenomenon now known as Hawking radiation. This discovery posed a paradox. If black holes were truly the ultimate sinks of information, how could they emit anything at all? In 1993, physicists Juan Maldacena and Leonard Susskind proposed a solution to this paradox. The information that falls into a black hole is not destroyed, but instead is encoded on the two-dimensional surface of the event horizon. This idea is at the heart of the holographic principle, the suggestion that the entire universe might function in the same way, with everything encoded on a cosmic boundary. This connection between black holes and the holographic principle suggests that information about the past is not lost when it falls into a black hole. Instead, it might be preserved on the event horizon, where it can be retrieved in some form, though we don't yet know how. If this is true, it raises the possibility that the past, or at least some trace of it, is imprinted on the fabric of the universe, much like the information in a hologram. The past as a cosmic imprint. If the past is encoded in the very fabric of space-time, the question arises, could we somehow access this information? Could we tap into the cosmic recording of history, either directly or through advanced technology? While we don't have the means to access this information just yet, the idea that the past is not lost but is preserved in the universe offers a radical shift in our understanding of time and history. Some scientists speculate that in the future, we might develop ways to read this encoded information, potentially allowing us to reconstruct the past in ways that we've never thought possible. If space-time records everything that has happened, then it might be possible, in principle, to reconstruct entire moments of history, accessing events from the past as though they were encoded data. Imagine if we could look into the cosmic record of the past, not just as memories or physical remains, but as an imprint, a lasting record of all that has ever occurred. Could we then witness historical events not as static memories, but as living data unfolding once again before our eyes? Could this offer a new way of accessing time, one that doesn't require time travel, but rather the decoding of the very fabric of space-time? The past, present, and future. As one, the holographic principle transforms our understanding of time, suggesting that the past is not something that disappears, but is preserved and encoded in the very fabric of the universe. The past, far from being gone, is still there, woven into the cosmos like a thread in a tapestry. The present moment, rather than being a fleeting instant, could be part of a larger cosmic continuum where the entire history of the universe is encoded, waiting to be accessed. Does our consciousness create time's flow? Imagine you are standing in a quiet room, watching a clock tick. Each second passes and the hands of the clock move forward, unwavering, predictable. Time flows moment by moment in one direction, from past to present to future. It feels real, doesn't it? But what if the flow of time, that steady march,
is not as objective as it seems? What if it's something that depends not just on the world around us, but on us, on our consciousness?
Could it be that consciousness itself, through the act of observation, plays a fundamental role in how we experience the flow of time? What if, like the observer effect in quantum mechanics, our awareness shapes not only how we perceive events, but also the very passage of time itself? Could the past, in some sense, still be happening, not as a static memory, but as a continuous process that is shaped by our consciousness as we observe it? In this section, we explore the profound question: does our consciousness create the flow of time, or is it simply a passive observer of a universe in which time moves independently of us. As we dive into the observer effect in quantum mechanics and its implications, we will challenge our assumptions about time, the past, and the role of consciousness in shaping our reality. The observer effect in quantum mechanics. At the heart of quantum mechanics lies a mysterious phenomenon known as the observer effect. In the quantum world, particles such as electrons and photons do not have definite properties, such as position or momentum, until they are observed. Instead, they exist in a superposition of multiple states all at once. It's only when an observation is made when the particle is measured that its properties collapse into a definite state. The observer effect is best illustrated through the famous double-slit experiment. In this experiment, particles are fired at a barrier with two slits. On the other side of the barrier, a detection screen records where the particles land. When the particles are not observed, they behave like waves passing through both slits, simultaneously creating an interference pattern on the screen. However, when an observer measures which slit the particle goes through, the particle behaves like a particle rather than a wave, and the interference pattern disappears. This seemingly paradoxical behavior, the fact that the act of observation changes the outcome of an event, is at the heart of the observer effect. The act of measurement of conscious observation appears to collapse the wave function, forcing the particle to settle into a specific state. But what does this have to do with time? If the observer effect shows us that consciousness plays a role in determining the outcome of quantum events, does it also play a role in how we experience time? Is the flow of time, like the collapse of the wave function, something that depends on our awareness of it? And if so, could the past still be unfolding in some sense, constantly shaped by our conscious observation of time? The flow of time as a conscious experience time, as we experience it, seems to flow predictably. The minutes pass, the hours stretch into days, and days become years. We perceive time as a continuous progression. The past is behind us, the future ahead, and the present is the fleeting moment we inhabit. But this perception of time is shaped by our consciousness. Could it be that the experience of time's flow is not something objective, but something constructed by our awareness? Research in neuroscience suggests that our brains construct the experience of time. We don't experience time directly. Instead, our brains interpret external stimuli like sensory information and memories to create our perception of time passing. In this sense, time is not a passive force that simply exists. It is something we actively create through the act of perception. Our perception of time is also highly variable. When we're deeply engaged in an activity, time can feel like it flies moments, slipping away in the blink of an eye. But when we're bored or anxious, time can seem to drag on, each second feeling longer than the last. This subjective experience of time suggests that our consciousness is not merely a passive observer, but plays a role in how we perceive the flow of time. Could it be that this subjective experience of time, where time seems to slow down or speed up, is not just a trick of the mind, but a deeper connection between consciousness and time itself? Could our awareness be shaping not just our perception of time, but the very flow of time, a living memory or a stilled moment? Now let's take this idea a step further. If time's flow is shaped by our consciousness, could the past still be alive in some way? Could the past exist not as a static memory, but as an ongoing, active process that is continuously influenced by our awareness? In quantum mechanics, time is not always as fixed and linear as we think. The uncertainty principle suggests that there are limits to how much we can know about a particle's position and momentum at the same time. Could it be that the past, like the uncertainty of quantum particles, is not entirely fixed? Could the act of observing the past, much like observing a quantum particle, influence how it exists, how it's perceived? Consider memory a key part of how we access the past. When we recall a memory, we are not simply replaying an exact recording of the past. Instead, we are reconstructing the past based on our current experiences, emotions, and mental state. Memories change over time. They are not static, fixed records, but are alive, constantly reshaped by our perception. Could it be that the past, in a similar way, is not something that is gone, but something that exists in a state of potential, constantly
reshaped and reinterpreted by our consciousness as we observe it? Could the past be revisited, not as an isolated event, but as a living, evolving process that continues to influence us in the present?
Does consciousness alter the course of time? If consciousness can shape our perception of time, what does this mean for the nature of causality, the relationship between cause and effect? In classical physics, causality is absolute. The past leads to the present, and the present leads to the future. But in the quantum realm, causality becomes far more fluid. In the quantum world, events do not follow a fixed cause and effect pattern. Particles can be in multiple states at once, and their behavior can be influenced by the act of observation. The observer effect suggests that the act of conscious observation itself has an impact on the outcome of events. What if this fluidity of causality extends to the flow of time? Could the act of observation influence not just the present moment, but the very course of time? Could it be that consciousness in some way alters the way the past and future are connected, shaping the flow of events in ways we don't fully understand? The nature of time and consciousness. As we explore the interplay between consciousness and time, we begin to see that time is not the simple, linear force we've always believed it to be. The observer effect in quantum mechanics tells us that consciousness plays an active role in shaping the outcomes of events. Could it be that our awareness not only shapes our perception of time, but also influences its very flow? The idea that consciousness is tied to the flow of time opens up profound possibilities for how we understand time itself. Could it be that time is not a fixed entity, but something that is constantly influenced by our awareness, something that is shaped by our observation? And if that's the case, does that mean that the past, though it may seem gone, could still be alive in some form, perhaps in the present, perhaps in parallel timelines, or even as a living memory? The physics of the Big Bang, time's beginning, and potential reversal. What if time didn't begin in the way we've always assumed? What if, instead of having a singular origin, a fixed starting point from which it all began, time itself is part of an endless cycle, forever repeating in a loop, where the past endlessly replays itself over and over again? For most of us, the Big Bang represents the beginning of time. This is when the universe began, about 13.8 billion years ago, when space, time, and everything we know exploded into existence from a singular, incredibly dense point. The Big Bang theory has been the cornerstone of modern cosmology, suggesting that the universe began as an infinitely small, infinitely hot point, and has been expanding ever since. But as we probe deeper into the nature of time and the universe, we begin to ask, is the beginning of time truly a singular event? Or is time itself part of a much larger, potentially cyclical pattern? Could time, in fact, have no beginning, but be part of an eternal process, a cycle, where the universe collapses, only to begin again? This section explores the origins of time, examining the Big Bang and its potential connection to cyclical cosmological theories like the Big Crunch and Big Bounce. Could time have not only started with the Big Bang, but also have the potential to reverse, to collapse in on itself, and begin again, forming an eternal cycle? And if time is truly cyclical, could the past never truly end, but instead continue to replay, forever reoccurring in an endless loop? The Big Bang, the beginning of time. The Big Bang marks what we think of as the moment that time itself began, at least in the context of our universe. According to the Big Bang theory, the universe began from an infinitesimally small point, known as a singularity, where both space and time were compressed into a state of infinite density and heat. In an instant, the universe expanded from this singularity, with space and time themselves emerging and stretching out in every direction. The idea that space and time themselves began in the Big Bang fundamentally changes how we think about the origins of time. In our everyday experience, we think of time as an independent backdrop against which events unfold. But in the Big Bang model, time is created along with space. Time isn't something that was simply always there. It is part of the very fabric of the universe, an inseparable dimension that emerges as the universe unfolds. However, the idea that time began with the Big Bang raises profound questions. If time had a beginning, does that mean it has an end? Could the flow of time, once it started, eventually collapse in on itself? Could the universe, this vast expanse of space-time, reach a point where the flow of time reverses and everything begins anew? Time's potential. Collapse. One of the most intriguing ideas that arises from the study of cosmology is the possibility of the Big Crunch, a theoretical scenario where the universe, after expanding for billions of years, eventually begins to contract. The expansion of the universe, as we know it, has been accelerating due to dark energy, but the Big Crunch theory suggests that if the universe's expansion slows down and reverses, all of the matter and energy in the universe could collapse back into a singularity. If this happens, the fabric of space-time would collapse and time itself could effectively reverse. The flow of time, which has been expanding since the Big Bang, would collapse back toward a point of infinite density, just as it was at the beginning. This would mean that time doesn't simply start and end, but folds in on itself, beginning again after the collapse. The Big Crunch theory suggests that time could have a cyclical nature, a never-ending loop in which the universe expands and contracts in an eternal cycle. If the universe were to collapse and then re-expand in a big bounce, the events that occurred in the previous iteration of the universe would potentially replay. Could this mean that the past, though it seems to have ended, is not truly gone, but simply waiting to be replayed in a future iteration of the universe? Time's eternal rebirth building on the idea of the Big Crunch is the concept of the Big Bounce. Rather than an end to time, the Big Bounce suggests that after the collapse of the universe, there would be a rebound, a moment when the universe re-expands from the singularity, starting a new cycle. In this model, time doesn't have a beginning or an end. Instead, it follows an eternal cycle of expansion and contraction. The idea of the Big Bounce proposes that time is cyclical, always reborn after each cosmic collapse. Just as the Big Bang marked the beginning of the universe we know, the Big Bounce suggests that the end of this universe would only give rise to a new universe, beginning the cycle over again. In this view, time is not a linear progression from past to future, but a repeating cycle, each iteration of the universe potentially containing a replay of the past. If the Big Bounce is correct, the past is never truly gone. It's encoded in the fabric of the universe, ready to re-emerge in the next iteration of the cycle. The events that happened in one cosmic cycle might reoccur in some form again and again. This challenges our understanding of time as something that moves in a one-way direction and suggests that the past might not be lost, but is part of an eternal cosmic loop. Time and the cyclical nature of the universe. The possibility that time could be cyclical introduces a profound shift in our understanding
of time itself.
If the universe expands and contracts in a never-ending cycle, with each collapse leading to a new expansion, it suggests that the past, present, and future are not separate entities, but interwoven within the fabric of time. Time would no longer be a straight line, stretching from beginning to end. Instead, it would be an endless cycle, with moments replaying themselves in infinite variations. This cyclical view of time implies that the past is not something that vanishes, but is part of an ongoing process, replaying over and over again in a cosmic loop. Could the past still exist in the fabric of space-time, encoded and preserved, waiting for the next cycle to unfold? Could we, in some way, access this eternal cycle, understanding that the past is not gone, but recycled as part of the continuous rhythm of time, a new beginning? If time is indeed cyclical, it challenges our traditional views of the end of time. In a universe governed by the Big Bounce, time does not end in the way we typically imagine. There is no ultimate endpoint, no final moment of collapse. Instead, the universe and time itself would experience an eternal renewal, with the cycle of creation, collapse, and rebirth continuing indefinitely. This raises another fascinating question. If the past, present, and future are part of a continuous cycle, then what does this mean for our perception of history? Is history a one-time event, or is it an eternal process that repeats itself, with each cycle building upon the last? If the past is part of a cyclical time, could our own history be playing out again and again in parallel universes or alternate realities where the events of our lives are constantly repeating themselves, ever so slightly altered with each cycle? Time as an infinite loop. As we explore the physics of the Big Bang and cosmological theories like the Big Crunch and the Big Bounce, we are confronted with a radically different view of time, one in which the past never truly ends, but instead is part of an endless cycle of expansion, collapse, and rebirth. If time is cyclical, then the past is not something that fades into oblivion, but something that is preserved and replayed again and again in an eternal cosmic loop. The Big Bang may have been the beginning of this cycle, but it is not the end of time. Time may never truly end, but instead continue to unfold in a series of eternal repetitions, with the past always alive, waiting to re-emerge in the next cycle. This view of time challenges our perception of history, suggesting that the events of the past may never truly fade, but instead continue to influence the present and future in ways we cannot yet fully understand. The philosophical implications.
Can the past be reclaimed?
The past is a strange thing. It shapes who we are, and yet it is constantly slipping through our fingers, lost in the stream of time. We often think of the past as something fixed, something that is gone, something that can never be changed. But what if that's not the case? What if the past is still alive, still happening somewhere just beyond our perception, waiting to be reclaimed? This question is not just a matter of physics or cosmology, it's a deeply philosophical one. Throughout history, philosophers have grappled with the nature of time, seeking to understand its flow, its purpose, and whether it's even possible to return to the past. From the linear time of Aristotle to the eternal recurrence of Nietzsche, philosophers have offered diverse views on time. Today, modern theories in quantum mechanics and cosmology challenge our traditional understanding, suggesting that the past might not be as fixed as we once believed. In this section, we explore the philosophical implications of a past that could still be happening somewhere, whether in an eternal cycle, a parallel universe, or within the very fabric of space-time itself. Can we access the past? Can we change it? Or is it forever out of reach? We will dive into the tension between determinism, free will, and the possibility that the past, in some form, might still be reclaimed or revisited. Aristotle and the linear view of time in the ancient world. One of the most influential thinkers about time was the Greek philosopher Aristotle. Aristotle saw time as a linear progression, where the past leads to the present and the present leads to the future. For him, time was the measure of change, a way to understand the unfolding of events. His view of time was tied to the idea of causality. Events follow one another in a sequence, with each moment being caused by the one before it. In Aristotle's framework, time is unidirectional. It moves from past to present to future, and it cannot be reversed. The past is gone and the future is yet to be realized. There's no room in Aristotle's model for the idea that the past could somehow still be happening, or that we could return to it. For him, time was a one-way street, a line that stretches ever forward with no backward motion allowed. But modern science and even certain philosophical traditions challenges this rigid, linear understanding of time. Quantum mechanics, cosmology, and even the idea of eternal recurrence suggest that time is far more fluid and complex than we thought. If the past is still happening somewhere, how does this fit into the framework of causality and determinism? A cycle of time. If Aristotle's view of time was linear, Friedrich Nietzsche offered an alternative, the idea of eternal recurrence. Nietzsche proposed that time is not a simple line but a cycle where everything, every event, every moment, every experience repeats itself infinitely. The concept of eternal recurrence suggests that the universe is not moving forward, but instead is trapped in a loop, the same events and experiences repeating forever in an unending cycle. For Nietzsche, the idea of eternal recurrence was not just a metaphysical theory, it was a challenge. He posed the question, what if your life, your choices, and everything that happens to you will recur eternally, forever and ever? Nietzsche's eternal recurrence asks us to confront time not as a finite progression, but as a never-ending loop, where the past, the present, and the future are all interwoven in a constant, eternal repetition. What does this mean for our relationship with the past? If time is cyclical and the past is replaying itself in an infinite loop, could we reclaim the past in some way? Could we influence it, change it, or even learn from it in ways that challenge our understanding of free will and determinism? Nietzsche's philosophy suggests that the past may not be as fixed as we think. It may be alive, constantly returning, waiting for us to interact with it, to make different choices that alter the course of its recurrence. The past as a fluid reality modern. Physics, particularly quantum mechanics, challenges our understanding of time even further. In the quantum realm, time behaves in strange and unpredictable ways. Particles exist in a superposition of states, meaning they can exist in multiple possibilities simultaneously until observed. The observer effect suggests that consciousness itself plays a role in determining the outcome of an event. This raises a profound question. Could consciousness affect the flow of time, allowing us to revisit the past in ways we don't yet understand? Some quantum theories suggest that time is not a constant, but a fluid and mutable experience. In the world of quantum mechanics, particles don't follow a fixed path, they branch out into different possibilities, creating multiple parallel realities. If time is truly fluid, it suggests that the past is not fixed in the way we think it is. It may still be accessible, not as a static memory, but as an ongoing reality that can be tapped into in ways we don't fully comprehend. This idea connects to the many worlds interpretation of quantum mechanics, which posits that every decision we make creates a new reality, a new timeline that exists alongside the others. If the past is not just a collection of events that have already happened, but an infinite set of parallel realities, then the past could be continuously replayed, and we might even be able to access it in some way. Could the past be a series of branches in time, where each version of reality exists alongside the others, waiting to be explored? Determinism, free will, and the possibility of reclaiming the past. If time is cyclical or fluid, it raises the question of determinism and free
will.
In a universe where time is a fixed, linear progression, events are determined by the past. The present moment is the inevitable consequence of everything that has come before it, and the future is an unalterable outcome of the present. This view of time aligns with the idea of determinism, the belief that everything is predetermined and that we have no true agency in shaping the future. But what if time is not linear? What if it is cyclical or fluid? If time is not a fixed path but an ongoing process that loops or branches out, does this mean that we can reclaim the past? Could our actions influence not just the present, but the very course of history, changing the past or shaping the future in new and profound ways? Could we, in some way, learn from the past, interact with it, and even alter its course? This question challenges the very nature of free will. If the past is not fixed, and if time is more
fluid than we realize, then it might not be the inevitable chain of events we think it is.
perhaps we do have the ability to interact with the past not as something that is forever gone, but as something that still exists in some form, waiting for us to engage with it in a meaningful way, the past as a source of wisdom and change even. If the past is not something we can directly change, there is still profound power in the idea that the past is alive within us, in our memories, our choices, and our experiences. Perhaps the true key to reclaiming the past is not to alter it, but to learn from it. If time is cyclical and the past is constantly replaying, then every moment is an opportunity to choose differently, to make a choice that shifts the course of events in new directions. In this sense, the past is not a burden, but a resource, a source of wisdom, knowledge, and potential for growth. If we can access the lessons of the past and apply them to our present choices, we have the power to reclaim the past, not by changing it, but by transforming our understanding of it. The flow of time is not set in stone, it is constantly shaped by our awareness, our choices, and our ability to learn from what has come before. The past, the present, and the future, as we explore the philosophical implications of time, it becomes clear that the past is not just a collection of memories or events that have already happened. The past, like time itself, is more fluid and dynamic than we ever imagined. Whether time is cyclical, fluid, or interwoven with our consciousness, the past is always alive, always present, and always ready to be reclaimed, whether through our memories, our choices, or our connection to the very fabric of time itself. The key tension between determinism and free will, between the fixed nature of time and the possibility of reclaiming the past, invites us to question everything we know about time, reality, and the power of our own consciousness. The past may not be gone. It may still be waiting for us to access it, to learn from it, and perhaps even to shape it in ways we never thought possible. The past, present, and future. One continuous whole. As we reach the end of this journey, we return to the question that has guided us throughout. Could the past still be happening somewhere outside of our direct perception? We've ventured through a vast landscape of ideas, from quantum mechanics to cosmology, from philosophical musings to scientific theories, exploring the very nature of time, the past, and the future. We've witnessed the unfolding of time in ways that challenge everything we thought we knew, and in doing so, we have begun to unravel the profound mystery of time's true nature. Throughout this documentary, we've introduced ideas that shake our conventional understanding of time. The block universe theory suggested that past, present, and future are not distinct, but rather coexist as part of a single, unchanging space-time block. We explored the holographic principle, which proposes that the entire universe, including the past, could be encoded on a two-dimensional surface, like a cosmic hologram, suggesting that time may not be the fluid, flowing entity we imagine, but rather something fixed and encoded in the fabric of space-time. We've even ventured into the idea that consciousness itself could be tied to the flow of time, with the observer effect in quantum mechanics raising the possibility that our awareness shapes not only the present, but the very passage of time. And yet, despite these mind-expanding concepts, one question remains at the forefront. Is the past really gone, or is it somehow still alive, still happening in a form we cannot yet perceive? The idea that the past might still be unfolding somehow beyond our immediate perception has profound implications not only for how we view history, but for how we understand our place in the universe. Revisiting the core ideas throughout our exploration, we've encountered many ways in which time is not simply a one-way progression from past to future. We've delved into the block universe, where time exists as a single, unchanging entity, suggesting that all moments in time past, present, and future are equally real. This theory challenges the conventional notion of time as a flowing river, suggesting instead that we are merely moving through a vast, fixed landscape of time, where the past is not gone but still exists in its own form, alongside the present. We've also explored the holographic principle, a radical idea that proposes the entire universe, including the history of time, is encoded in a two-dimensional surface. This theory suggests that the past is not erased, but preserved in the very fabric of space-time itself. It implies that we might not need to travel backward in time to experience the past. It could still be encoded in the cosmos, just waiting to be decoded. These theories hint at something profound. Time is not linear, nor is it simply a force that flows unidirectionally from past to future. Instead, time may be more like a landscape with the past, present, and future all existing simultaneously, waiting for us to interact with them in ways we don't yet understand. The idea that time could be cyclical or reversible suggests that the boundary between past, present, and future might not be as fixed as we've been led to believe. The interconnectedness of past, present, and future. As we tie together the threads of this investigation, we are left with an intriguing possibility. What if the past, present, and future are not separate entities, but part of one continuous whole? If time is not a river flowing in one direction, but rather a vast, interconnected web with all moments existing simultaneously, then the distinction between past, present, and future might be far less meaningful than we've thought. Consider the implications for history. If the past is not gone, but encoded in the very fabric of space-time, then history itself might not be the static, fixed set of events we've always assumed. The past could be alive, still influencing the present and the future in ways that are beyond our perception. We might be more closely connected to the past than we realize, with the events of history not fading into oblivion, but instead interwoven into the ongoing flow of time. If time is a continuous whole, then the idea of reclaiming the past takes on new meaning. Perhaps the past is not something we can change or return to in the traditional sense, but something we can revisit, relearn, and reinterpret through the lens of our consciousness. In a universe where time is more fluid, more interconnected, could the past be reclaimed, not as a fixed sequence of events, but as an ongoing process that continues to shape us now in the present? The role of consciousness in time's flow. The question of whether we can reclaim or access the past leads us to one of the most profound implications of our exploration: the role of consciousness in shaping time. The observer effect in quantum mechanics suggests that our awareness, our consciousness, plays a key role in how reality unfolds. If consciousness can shape the way quantum events collapse into definite states, could it also shape the flow of time itself? This idea has far-reaching consequences for how we understand free will and determinism. If time is not fixed and linear, If it is fluid and intertwined with our perception, then the choices we make in the present could have far more power than we realize. The past is not simply a record that has already been written. It might be an ongoing process, something we can continue to influence even as we experience it in the present. This opens up new possibilities for how we understand agency, choice, and the very nature of time. Time as a cosmic mystery. The theories we've explored suggest that time is far more than we've ever imagined. The block universe, the holographic principle, the idea of eternal recurrence, and the implications of the observer effect all point to a universe where time is not a straightforward, unchanging force, but something far more fluid, interconnected, and alive. Time, it seems, is a cosmic mystery, one that stretches beyond our current understanding, inviting us to reconsider our place in the vast web of existence. If the past is still happening, if time is not simply a one-way flow, but a continuous, eternal process, then perhaps we are not mere spectators in the story of time, we are active participants, shaping the past, present, and future with every thought, every action, every choice. The boundary between past, present, and future may not be as clear as we've been led to believe. Time might be more like a river, yes, but it could also be a tapestry, woven together by the choices of every observer, every conscious being, across time and space. Time as an eternal mystery. As we reflect on these ideas, we are left with a sense of wonder, a feeling that the true nature of time and our place within it is still an eternal mystery. The past, the present, and the future may not be as separate as we thought. Instead, they might be part of a continuous whole, an ongoing dance between consciousness and cosmic reality. The theories we've explored suggest that the past is not lost, it is preserved, alive, and interwoven with the present. Time, far from being a simple, linear progression, is a complex, dynamic force that exists within the fabric of the universe, shaped by our awareness and experience. Could the past still be happening somewhere just outside our perception? It's a question that, while we may not yet have the answer to, invites us to continue exploring the very nature of time, history, and our place within the cosmic flow.